What is absolute zero? Absolute zero is the temperature at which all motion stops. So how absolute zero is determined? It is determined by conducting an experiment where we can observe the lower the temperature, the lower the pressure inside of the sphere, where there will be no pressure yield, absolute zero, which is about negative 273.15 degrees Celsius. So what are the importances to observe absolute zero? First, understanding the behavior of matter at extremely low temperature. Second, many practical applications involve the use of extremely low temperature. And third, extremely low temperatures provide unique environments for study.
Hi, my name is Muhammad Mazami. I'm gonna explain to you guys of one of my current research on approaching absolute zero and the associated cooling technology. First and foremost, quantum gases and Bose-Einstein condensate (BEC). In this BEC, the atoms all congregate in the lowest quantum state of the trapping potential well, and the atomic wave packets behave as one giant coherent matter. So if you guys watch this picture below, it's showing that classical gas, when it's cool, it separates to bosons and firm ions.
The second key aspect or technique related to approaching absolute zero is dilution refrigeration. This method involves diluting a parametric salt in a liquid. When the salt is exposed to a strong magnetic field, it aligns with the field, causing the liquid to absorb heat and cool down. The third one is laser cooling. Laser cooling refers to the variety of techniques used for cooling down atomic and molecular samples to a near absolute zero temperature.
Hi everyone, I am Siti Nurfatiha, going to explain why it is impossible to observe absolute zero. According to the third law of thermodynamics, reaching absolute zero in a limited number of steps is not likely. It gets harder and harder to remove the last of the heat from a system. Why it is impossible to observe it is because when temperature approaches absolute zero, the quantum effects become dominant, and the particle behavior will be unpredictable, such as particles will come in a state of minimal motion.
So, the object with higher temperature will cool, while the object with lower temperature will become hotter. Now, the zero value in absolute zero makes sense. Absolute zero is the temperature at which the particles in a substance are essentially motionless. There's no way to slow them down further. As we know, it's actually impossible to have temperature lower than that. We can see in this picture, when it is at 0 Kelvin, it is negative 273.15 in degrees Celsius and negative 459.67 degree Fahrenheit. So, it's impossible to get temperature lower than that.